Hi everyone, in this video I will show you how to calculate the molar mass of a compound, and I will be going over a few examples. So these are the examples that I will be going over to help you understand how to calculate molar mass. So let's get started. So the mass of 1 mole of a substance is known as molar mass. Molar mass, it's also known as molecular mass, molecular weight, formula unit. So these are just another name for molar mass, but they mean the same thing. Okay, so if you look at your periodic table, this is what you're going to see. So let's look at oxygen. So the top number that you see here, this number is known as the atomic number. This is the name of the element, so it is oxygen. O, it's the symbol of oxygen, and 15.999, this is the atomic mass. Okay, so molar mass, like I said before, it's mass of 1 mole of a substance. So 1 mole of oxygen is 15.999 grams. Okay, let's do a few examples to understand this even better. Let's start with our first example. We have Cl2. It's also known as dichlorine. So let's look at the periodic table first to find out the atomic mass of chlorine. So if you look at your periodic table, you will see that the atomic mass of chlorine, it's 35.453. See here? This one. So it is 35.453. But remember, this is the mass of 1 mole of chlorine. Okay? So we had 35.453. So that's for 1 mole of chlorine. But here we have 2, right? So that's why we have to times this with 2. So we're just going to time this with 2, and then we will get 70.906. If you want, you can round this to 2 decimal places, so 70.91. Okay, one important thing you should remember is that the unit for molar mass, it's gram per mole. Okay, so that's the unit for molar mass. So for our second example, we have MgF2. This is also known as magnesium fluoride. So again, if you look at your periodic table, you will see that the atomic mass of magnesium is 24.3050. So for this, we are just going to times this with 1 because magnesium doesn't have any number with it. It's without any number. That means it's just 1 mole of magnesium. Then we have to put plus because we have to add the mass of all the elements. Okay, so we have here 2 moles of fluorine. So we write 2, then we put the parentheses. 1 mole of fluorine is 18.99840. Okay, so after we do the calculation, we get 62.3018. Okay, so we're just going to round this to 2 decimal places, so 62.30 grams per mole. For number 3, we have H3PO4. That's also known as phosphoric acid. So we need to first find the atomic mass of hydrogen. The atomic mass of hydrogen is 1.00794. But we have to times this with 3. That's because we have 3 moles of hydrogen. Then we write plus. We have to find the atomic mass of phosphate, 30.97376. We have to times this with 1 if you want, but if you don't want, you can also leave it without timesing it with 1. Then I write plus, and then I write the atomic mass of oxygen, which is 15.9994. But remember again, I have to times this with 4 because I have 4 moles of oxygen. So I'm going to times this with 4. At the end, I have to add all of them together. So this gives us an answer of 97.99358. We're going to round this to 2 decimal places. We get 97.99. Okay? And then we need to write down grams per mole because this is the unit of this, of molar mass. For number 3, we have PB, NO3, parentheses 2. This is also known as lead nitrate. So if you look at your periodic table, you will see that the atomic mass of lead is 207.2. Plus, we write the atomic mass of nitrate. So let's look at here. For nitrate, we don't actually have 1 mole of nitrate. We have 2 moles of nitrate because we have the parentheses, we have a subscript after the parenthesis, which is 2. So that means it's not just 1 mole of nitrogen. It's actually 2 moles of nitrogen because here inside the parentheses there is just 1 nitrogen, but we have to times this 1 with the subscript, which is 2. So 1 times 2 is 2. So that's why we're going to write 2 moles of nitrogen. So we times 2 with the atomic mass of nitrogen. The atomic mass of nitrogen is 14.0067. Okay? Then we write plus again. We don't write 3 moles of oxygen because we have 2 as the subscript. So that's why we have to times this 3 with the 2. That will give us 6. So that means we have 6 moles of oxygen. So we write 6 before the parentheses. Inside the parentheses, we write 1, the mass of 1 mole of oxygen. So 1 mole of oxygen is 15.999. Okay, so we write that. Then we just have to add all of them. So if you add all of them, you would get 331.214. So 331.214. Again, we're just going to round this to 2 decimal places, so we get 331.21, and then we have to write grams per mole. Okay, so again, just to clarify that, remember that it is nitrate, it's 1 mole of nitrate, but here we have a subscript which is 2, so that means we have to times 1 mole of nitrate with 2, 3 moles of oxygen with 2. Okay, so just be careful about the subscript. So for our 5th example, we have NH4. I forgot to put the subscript, it should be 3. So we write the subscript, which is 3, then PO4. So the name of this compound, it's ammonium phosphate. Okay, so let's look at our periodic table and find the atomic mass of 1 mole of nitrogen. 1 mole of nitrogen, it's 14.0067. But remember, we have to times this with 3 because we have a subscript of 3. Okay, so inside the parentheses, we just have 1 nitrogen. But that's not it. We have to times this with 3 because we have here 3 moles of ammonium, right? So we are going to times this with 3 plus, we don't have here 4 moles of hydrogen. We actually have to times 4 times 3. This will give us 12. So we write 12, then we write inside the parentheses the atomic mass for 1 mole of hydrogen. So 1 mole of hydrogen is 1.00794. Okay, we write plus again. We write the atomic mass of phosphate. The atomic mass of phosphate is 63.996. Again, plus. Then we write the atomic mass of oxygen. The atomic mass for oxygen is 15.999, but we have to times this with 4 because we have here 4 oxygen. So we times this, we just add all of them. After adding everything, we get 149.08514. Then I'm just going to round this to 2 decimal places. I get 149.09 grams per mole. So that's the atomic mass of ammonium phosphate. Example. So for our last example, we have CuSO4 dot or decimal 5H2O. So before I do this example, I just want to let you know that this decimal here, it does not mean that we have to multiply the mass of this with the mass of water. So this is copper 2 sulfate and this is water, pentahydrate. Okay, this 5 here, it's a coefficient, it's not a subscript, so that does not mean that we have to times 2 moles of hydrogen with 5. We have to find first the mass of copper 2 sulfate. After we find that, we just have to add the mass of this with the mass of pentahydrate. Again, we are not going to times the mass. Okay, let's begin. First of all, we have to find the mass of copper 2 sulfate. So the mass of copper from the periodic table, you will get 63.546. We are going to times this with 1 because there is just one copper, so 1. Then we write plus the mass of sulfur, it's 32.065. Again, we're going to times this with 1 because we have 1 mole of sulfur, plus we're going to times 4, 15.999. 4 because there is 4 moles of oxygen. Next, we have to add all of them. So after we add all of them, we would get 159.607 grams per mole. So again, this is the mass of copper 2 sulfate. That's for copper 2 sulfate. Now we're going to find the mass of water. So we have here 2 moles of hydrogen. Okay, so again, we are not going to times this 2 with 5. It's not 10 moles of hydrogen, it's just 2 moles of hydrogen. So we write the atomic mass of 1 mole of hydrogen, which is 1.00794. We have to times this with 2, which is the subscript for hydrogen, plus we write the mass of oxygen. So 1 times 15.999. After we add, we get 18.01488 grams per mole. So remember, this is for 1 mole of water. This is the mass for 1 mole of water. Okay, but here we have 5 moles of water. So that means we have to times this with 5. And that will give us 90.0744 grams per mole. That's the mass for 5 moles of water. So I'm just going to write here 5H2O. That's the mass for 5 moles of water. Then what we have to do after this is that, remember, this dot, we're not going to times them. We have to times this mass with this. So let's do that. We're going to write the mass for copper 2 sulfate, so 159.607 plus the mass of pentahydrate, which is 90.7, sorry, it should be 90.0744. So after adding 90.0744 plus 159.607, you will get 249.6814. So we are just going to round this to 2 decimal places. Okay, then we get 249.68 grams per mole. So this is the molecular weight or the molar mass for copper 2 sulfate pentahydrate. That's all I have for you today. I hope these examples are helpful to you, and if you found this video helpful, then please hit the like button, and also please subscribe to this channel for more videos like this.